Hi guys, it's Shah here, the Tech Borg, and today's video is going to be on GCSE Computer Science. I thought it's worthwhile putting something up for this, because, I mean, your GCSE has changed, so I thought maybe I could give you something that could help you, I guess, for your GCSE, and yeah, here I am. So you have to know about the CPU fairly well. I mean, you've got multiple components to the CPU. You've got the von Neumann architecture that you have to know about, which is separate to what I'm going to teach you at the moment. So at the moment I'm just going to go over the basics with you, and that's just literally the CPU. So as you can see, we have the central processing unit here. This is our input, so this is all the data that's entered into the system as binary and all that, and that's all processed by the ALU, which is the arithmetic logic unit, which is all the number crunching, where it basically occurs, number crunching, and this actually all works with the RAM and memory unit and the storage together. So I think this cache and RAM is written incorrectly, but I'm just going to use this as an example anyway. So this is a very good example to show you how cache works as well. So the cache is a very small unit, as you can see in this entire section, and clearly it takes less space, and we know that it doesn't take more than a few megabytes of space. And the memory unit, as you can see, it takes like the most space, and yeah, and your memory unit is the RAM cache, but the main component of the memory unit is RAM, I guess, because yeah, so your RAM is like 4 GB, 8 GB, cache is like 8 MB or 4 megabytes, ROM is like, I think, even smaller. It's just read only, so it's like stuff that's required to start up the computer, so like key files basically, and then that's connected to your storage. So you enter something into the system to run, and it's going to go through the arithmetic logic unit, which is going to process your request, and then to actually run the program, it's going to have to get all the files from the storage, and it can get the files from the storage really quickly if you have more RAM, because it can operate more in one go, and it can also get files really quickly, or open them up really quickly, applications, if you've got larger cache. So cache works by saving your frequently used applications or programs by launching them really quickly later on, if you use them very frequently. For example, like if I use Google Chrome a lot, it will launch it really quickly compared to normal speeds, and yeah, and it's very straightforward. I think this is another decent example of how it looks like. So you have your registers here, which are connected to the control unit, and the ALU inputs, outputs, and the RAM. So I think this is a much better method, I guess, of showing it. It's just it looks visually better, I think. But yeah, it's very straightforward. I think there's not many good examples, but this is a very good example. Very simple and good to understand. So input, and then the stuff actually will move around between these three units and then get to the output. So as I explained to you earlier about how it goes from the ALU to the memory, and then memory to the hard disk, and in between them it works, and the control unit there for the outputs. And yeah, I mean, if you have a look on Google, I'm sure you'll find something useful. But there's not many. I mean, I searched up CPU parts, but clearly there's not much. Okay, there's one over here, I guess. CPU and memory are connected. Poor picture, I guess. And yeah, and what normally I get confused about, like when I used to be doing GCSE computer science, is just, I guess, understanding the bits. I mean, sometimes I used to be like, what's this? And just to make your life easy, let me just explain to you the kind of errors I would encounter sometimes. So sometimes I sometimes just get like tilted, like sometimes I just get like shocked over like a question, or if it asks me like define the purpose of the arithmetic logic unit, or define the purpose of like memory unit. So sometimes it can be daunting, like you could get confused. So I mean, it's entirely normal, and I think I'm just gonna go over like the types of questions they can ask you as well. So for example, sometimes they can ask you like to apply your knowledge. So sometimes they could say explain how the CPU works, and then you obviously talk about the fetch, decode, execute cycle. But then there might be a part B to that, and then they might say explain the different parts within the CPU, not the actual like processing parts. They want you to talk about like the bits involved. So the bits in this case are, as we talked, arithmetic logic unit, your memory unit, and then your control unit. I'm pretty sure the control unit isn't in the specification, but I'll give it a check again just in case. But arithmetic logic unit you must know, and memory unit you must know. Memory unit is straightforward. I mean, it's your what was it? We went over it. It was your main memory. So was it your RAM, ROM, and cache? So those three are stored within your CPU, and they take very small amounts of space. Well, your RAM isn't stored in the CPU technically; it's a separate unit, but it's just we just say that it's part of the CPU because the CPU just uses it as if it's native. But I think I'm just going too far fetched right now, so I'm just gonna stay within the range. So as I was saying, I mean, so you want to make sure that you talk about your memory unit and talk about the three components of the memory unit: ROM, RAM, and cache. Talk about cache and RAM more specifically in detail. Explain how if you use a program frequently, it will transfer you through the cache, and the cache is significantly faster. Which is why, I mean, higher CPUs have more cache design, which is also why they're very expensive as well. So yeah, that's I guess an example. I guess I could show you. I guess. But yeah, I mean, thank you for watching, guys. I hope you guys enjoyed. And again, thank you for watching. Like, comment, subscribe.